All right. So with 130, as a reminder, if you don't recall from last semester, you have 25 questions and 1 hour to complete that. So we're going to go through and answer some of these questions that you may have. And I'm going to try and keep up with what you guys are putting in here into the chat. So just bear with me and put it in the chat. I appreciate you guys asking these questions, and then we'll get through that. Through the process of answering the questions, Teresa, I will be, or Teresa, I apologize if I'm mispronouncing your name. I will be doing dimensional analysis, so you will see that reviewed. And also, if you go to my YouTube page, and that's just by going to Dr. Rad, the Rad Tutor. If you just do a search for that, Dr. Rad, D-R-R-A-D, YouTube, you'll see my picture, which is the same picture that shows up in my profile here. And then that way you'll see the same things I've already posted, and then most of that stuff is already in dimensional analysis. So, oh, I just found the secret that I was looking for. Here we go. Good. Now we're in business. Okay. It was hiding. See, we just wait around and we'll eventually get to the answer we're looking for. All right. So let me go ahead and, so I'm guessing someone said, never mind. Oh, okay. That's fine. I'll still do it. Let me first start off with just an overview of the, when we talk about dimensional analysis, it's basically the same thing that you've been doing. If you do the desired over have or the ordered over have times the quantity, we're just basically rewriting or it's just a strategy to put things in an orderly fashion. I find that a lot of times the trick to doing drug calculations is just having a system that you can be consistent with and do that. Yeah, so my page is being shared, so you may need to just highlight. Oh, wait, no, I don't have that as a thing there. We'll see if this does it. Nope, that's not what we wanted. Now you should be able to double click on my window, and it should make it big for you guys. So try that out. But when I record it, it'll look like this. You won't see all the other things. Let's just see here. Yeah, even if you click in the upper right hand corner, there's a view and click on speaker. That should help that out. If not, then I promise you will see this on in big on YouTube. So I apologize if it's too small, but I do talk through all these questions. So so let me just start off with a basic how you would use dimensional analysis to solve like a question, like let's say question number 7. Now question number 7, most of you probably are pretty straightforward, and you can say like, oh, I know 500 milligrams is ordered. We have 250 milligrams on hand. I'd give them 2. And you can do that in your head, no problem. And sometimes just taking that initial step for setting up your questions is what's going to be helpful for practicing dimensional analysis, the ones that you already know the answers to. That's kind of my secret, is I just start with something I know the answer to already, and then kind of build it from there. So the way I set something like this up is I always start with what the order is. So 500 milligrams. So if you can't see that I wrote 500 milligrams, that's what I wrote. And then I'm going to start my dimensional analysis. I don't want milligrams, so I put that in the denominator. I do want to know capsules, so caps. I look at my label. So I'm looking at question 7. Question 7 label says we have 250 milligrams of the cephalexin. So 250 milligrams per capsule. So I just put that information, 250 milligrams per 1 capsule. And then when you do your math, you can plug that into the calculator. Good strategy for using your calculator, multiply across the top, divide by the bottom, and then you get 2 capsules.
Excuse me.
Yes.
I'm sorry to interrupt, but Does it matter that we have a different practice test?
It
Are the
shouldn't.
questions
Um,
recycled?
it shouldn't. So this is the most current one that I have, but if someone wants to email me the updated one, I can print it off.
Okay.
Because I'm the one who creates these practice tests. So I don't know why it would be different.
All right.
So thank you for letting me know. But no, it won't matter because the problems are basically the same. They're just written out differently. So.
Okay.
Yeah. And those are Z's, not upside down twos. I understand that my handwriting's terrible. Yeah. So if you have a different test, just email me a copy of it and then I'll pull it up and print it off. But I'll so okay. So what I just did as number 7 is 9 for you guys. Okay. Yeah, that's okay. It's just some of these might just be reordered, reorganized. So I don't know who did that, but it's okay. It won't change anything that we're doing. So if you want to you know, in your question, when you say like what question you want worked out, just tell me like what drug it is. And maybe I can find it on mine, but I'm going to check my email here and see if you guys, someone sent that to me. Okay. Nothing yet, but I'll pay attention to when that shows up. So, well, anyways, getting back to this question, which is number 9 for you, number 7 for me. This is just how you would set up or how I set up my dimensional analysis question. Some of you prefer, like when you're doing dimensional analysis, that you have it over 1. That's perfectly fine. It's not required. If you're doing desired over half for this question or ordered over half, I'm sorry, 500 milligrams is what was ordered. And then you have available 250. And then your quantity is the 1 capsule. Sometimes that's 1 milliliter. Sometimes that's 5 milliliters. It just depends on what it is. And then you get the same outcome depending on how you want to do that. Okay. All right. So since it was thrown up there and you guys said that question 20, and I see your D5W question, so we'll get to that. But your question 20, I know you said you got it figured out. What was that question? Was that that wasn't the sliding scale question, was it?
No, it was the physician ordered 1440 cc's of the D5. So it might be the same question, unless there's another D5 question.
With a big
Nope,
picture.
there's multiple.
Okay, thank you. So
10
is
drops.
it
Yep.
this question here?
Yes, sir.
1440 cc's. Okay.
Yes, sir.
So we'll do that one. So this is a flow rate question. So this, I think this is new for you guys this semester. I don't think you did that in first semester. So flow rate, there's a very specific formula to kind of follow. So you can do dimensional analysis, but if you ever get stuck with these, the formula is flow rate times the drop rate or drip rate equal, I'm sorry, the drop factor equals the drop rate. Okay. The other pieces of information that are helpful for this is drop rate is going to be in drops per minute, always, at least here at CCAC Allegheny, that'll be what it is. Your drop factor is always going to be drops per milliliter. And your flow rate is either going to be one of 2 things. It'll either be milliliters per hour or it'll be milliliters per minute. So either one will be the drop factor. Okay. If it's in already minutes, leave it alone. If it's in hours, convert it to minutes. And those are just kind of some of the shortcuts with these types of questions. So your question 20 says the physician ordered 1440 cc's of dextrose 5% normal saline to be infused over 12 hours. If your tubing is labeled as below and the label says 10 drops per milliliter, what will the flow rate be in drops per minute? So when you're solving this question, you start off with the flow rate. So the flow rate is the 1440 cc's, which you know is the same thing as ml, per 12 hours. Okay, so we know that from the get-go. Your flow rate or your drop factor, I'm sorry, is 10 drops per milliliter. And then we are going to solve this. So there's a couple ways you can do this. You can right off the bat just convert hours to minutes. You could set up another dimensional analysis to do that. The shorthand way that I like to do this is if you do 1440 over 12, if you just reduce that, so 1440 divided by 12, if someone can do that, because I don't have my calculator in front of me, I'm pulling it up right now. I think it's 12, or I'm sorry, 120, but I'll double check. Yeah, 120. Thank you. Yeah. So for this ratio, so I'm just kind of diverting from my typical strategy of doing dimensional analysis. This is 120 cc per hour. Okay. So you can do it that way. Some students prefer to convert hours to minutes. So 12 hours is the same thing as 720 minutes. But there's like an extra like kind of setup step here that would be helpful. Or if you're doing dimensional analysis, you could just solve this as is and just remember to convert hours to minutes. Or you can set this up as 1 hour, 60 minutes. Another trick and why if you guys had me at all last semester, I like to use dimensional analysis because then we can eliminate things and then we know what we're left with. And we know that we've set up the problem right without doing any kind of math. So we're not guessing when we do this as best we can. Okay. So 120 over 60 is the same thing as 1440 over 720, which is 2 times 10 gives us 20 GTT per minute. Again, the other thing you could have done is, and I gave you various ways, so don't get confused by all this side stuff. The way I've set it up here, for those of you who like to do dimensional analysis, this is the correct dimensional analysis steps laid out. So you would do 1440 times 10 divided by 12 divided by 60, and that would give you 20 drops per minute. All right, someone else mentioned question 23. What does that question start with? Okay. Oh, okay. The combo. So your question 23 is my, oh, okay. So I realize this test has more questions on it. Is my question 29. Okay. So this practice test that apparently I have here is more, and I'll give you the link to this so you can actually, if you want to practice some extra questions, you'll have it there. Okay. And then Chelsea, I see your email, so I'll get that updated in just a second. So thank you. So 29 or my 29 is your 23. So the trick to this is we already did a question like this when we calculated the capsules for the cephalexin, the antibiotic. We're just going to basically do that math twice. We're going to calculate the milliliters of Vistaril. We're going to calculate the milliliters of meperidine, and then we're going to add those 2 milliliters together. So let's do that real quick. All right, so the question says the patient has ordered Vistaril 50 milligrams and meperidine 45 milligrams. So we're just going to say this is the V, this is the M. And we want to know how much of the total volume for the medication for the injection. So Vistaril is available at 50 milligrams per milliliter. So setting up my dimensional analysis, I don't want milligrams, I want milliliters. It's 50 per 1. So that's a pretty straightforward setup there, 1 milliliter. Then 45 milligrams for the meperidine. It says it's 75 milligrams per milliliter. I'm going to do 45 divided by 75. And I'm going to get 0.6 milliliters. Then I'm going to take these two and I'm going to add them together. And I'm going to get 1.6 milliliters for the total injections. This is very similar to when you're mixing insulin, except they're not asking you about, mixing anything and where you mark the syringe, but you would add, the milliliters of one, the milliliters of the other, and get the total milliliters there. Yeah, so I'm not going to email people individually. I will post in the chat the link. So I'll get that out to you guys in just a second. Okay. Actually, let me do that now since most of you are here. May actually have this already set up. Oh, I do. And if I add anything new, it'll be here in this area. So I'm going to put this into the chat here. And then you guys can just pull it up on your own. The first link is to my my Microsoft OneDrive. You can open it up and you can download everything that's in there. And then the other one is a link to the YouTube channel in case you don't already have that. So, I actually just sent that only to one person. So, all right, here, we try that again. Okay, now everyone's got it, other than the last person who DM'd me. So, yeah, so the question, these practice tests are meant to mirror your actual tests that you'll get next week. So yeah, if you could do these questions, you should be fine. The only difference is they might use different medications or they might use different numbers. So, okay. Are you for John? Are you saying that the Visceral and Mepridine? Oh, okay, yes, that's fine. Yeah, so we can certainly do the variation on this. Absolutely. So the alternative Visceral and Mepridine, you'd set up exactly the same way, except you'd put a 60 here and you'd put 85 here and then solve it the same way. Now, I think what might be tripping people up is the and yes, I'm switching colors here just to kind of make things a little bit more interesting, is that you have to do some rounding. So let's set this up. 1 milliliter, 50 milligrams, and then 85 milligrams, 1 milliliter, 45 milligrams. All right, so when we do this, we're going to do 60 divided by 50, and I believe that's just, 1.2. Okay, so no rounding needed here. And then 85 divided by 45, this is where we get something that looks like this, 1.8888 on and repeating, right? So you get all those eights. You're going to round that number to 1.9. Okay. I just want to make sure I wrote down the right numbers. Yeah, okay. You're going to round that number to 1.9 and then add these two together, okay? And you're going to get the 1.9 plus 1.2 is a total injection of 3.1 milliliters. Yeah, so anytime when you're rounding with rounding, if the number is greater than 1, you're going to round to the 10th place. If the number is less than 1, you're going to round to the 100th place. So as an example, if you had 1.85, you would round that to 1.9. And then for here, if you have an answer 0.856, you would round that to 0.86. Okay. and then whatever if it's milliliters, whatever it happens to be. Oh, okay, so it's just you had 75 as, so it was just a different label. Okay. I'm pulling up your test now. See it. Pepperdine. Okay, so 75. Oh, I apologize. I did write 45 and that should have been 75. So that's on me. So anyways, I just showed you an alternative way to do this. You are correct. It's supposed to be 75. So I made that mistake because I was going to say, I thought the answer was a little bit different. So apparently I need more coffee, guys. All right. Yeah, so 85 divided by 75 would give you 1.13. So let's just start that over again. 1.13333 repeating, you would round that to 1.1. 1.1 plus 1.2 would give you 2.3 milliliters. So I apologize. Okay. Yes, I can go over 18. All right, so that's the sodium chloride. It's another flow rate question. So I'm just gonna pull this monstrosity here. So question 18. Okay, thank you. There we go. Now we're getting some questions coming in. So question 18 is we have the orders for 0.9% sodium chloride, 500 milliliters IV at 125 milliliters per hour. How long will this infusion take? Okay, so a couple things just to keep in mind with when we talk about infusions and flow rates and things like that. So a flow rate is what? Flow rate is the volume over the time. And typically when we talk about just basic flow rate, it's milliliters per hour, it could be cc's per hour. So flow rate is not much different than any kind of rate. Any kind of rate is something over time. So think about when you're driving a vehicle, you go miles per hour. And then if any of you from Canada, kilometers per hour. And we measure that speed. So it's the same thing. If you put it in something you're a little bit more familiar with, like let's say you live 10 miles away from CCAC, you're traveling, 25 miles per hour on your way to CCAC. How long will it take you to get there? You can calculate your time. You have an idea if you're going 100 miles per hour, if you're going 10 miles per hour. So with flow rate, with this question, we're asking, we have a starting volume of 500 milliliters, and it's infusing at 125 milliliters per hour. So you're going to do the same thing with the dimensional analysis if you want to do it this way. Okay. If you're doing ordered over half, you would just do 500 divided by 125. But the reason, again, I show you this way is because I can easily, first of all, show you why I'm doing it this way. I can show you the volume, I can show you the rate, and then times the hour, and that gives me 4 hours. If you instinctively got 4 hours because you just said 500 divided by 125, you're doing that exactly right. All I'm doing is verbalizing or visualizing the things that you're doing in your head. So that is really the only and main difference in that regard. All right, 21. So 21. Okay, so it says an order requires 60 milligrams of a drug to be administered intramuscularly stat. The vial has the following 3 choices of strength after reconstitution. So it says 5 milligrams per milliliter, 10 milligrams per milliliter, and 20 milligrams per milliliter. And it says determine the volume in milliliters for the strongest concentration. So the strongest concentration is what? It's the one that's going to have the most milligrams per milliliter. Okay, so we start off with our order, which is 60 milligrams. Then we take our strongest concentration because we're looking for how many milliliters to administer, and that's 20 milligrams per milliliter, and we get 3 milliliters. All right, question 24. Okay, so question 24 says you have Dilantin, 15 milligrams per kilogram loading dose by mouth. Then you're going to give the patient 300 milligrams per day as maintenance dose. For the loading dose, okay, how many milligrams of this anticonvulsant would you administer to the patient who weighs 176 pounds? So step one is ignore the 300 milligrams. The 300 milligrams per day we're not even going to touch that because that has nothing to do with the loading dose. The loading dose is the 15 milligrams per kilogram, and that per kilogram tells you two things. We got to account for the patient's weight, and we need to convert the patient's weight in pounds to kilograms. So step one, convert the patient's weight in pounds to kilograms. And you're going to do that by dividing by 2.2. And I believe that's 80, but let's double check. So 176 pounds divided by 2.2, and we get 80 kilograms. Okay. Then we're just going to take that 80 kilogram patient's body weight times the loading dose, which is the 15 milligrams per kilogram. We know we set it up right because we can eliminate kilograms and we'll be left with milligrams. And then you do 80 times 15 and you'll get 1200 milligrams. Now, the question says, how many milligrams would you administer? If this question had said, how many grams would you administer? You would convert this to 1.2 grams by dividing by 1,000. But I think you guys know how to do those conversions. At least my hope is that you know how to do those conversions. All right, so that was 24. Going back to 22. Actually, I'm already on 25 in the same screen. So let me do 25 and then we'll go back to 22. So if I forget, please let me know. All right. And then I also see this, there's another question here about 19 and I'll get that straightened out as well. So I'm not ignoring anybody. 25 says the physician prescribes 500 micrograms of entecavir per day via NG for a patient with chronic Hep B viral infection. The oral solution contains 0.05 milligrams entecavir per milliliter. How many milliliters of this antiviral would you administer? So you have two pieces of information that you need to work with. You have the order, okay, and then you have the available. Now, you can't do math, at least not easily and efficiently, when one's in micrograms and one's in milligrams. So they both need to be in the same units. You get to choose what you want to do. So if you want to convert milligrams to micrograms, great. Or if you want to convert micrograms to milligrams, great. But you only need to do that to one of these. So I'm going to go ahead and convert the 500 micrograms to milligrams because I know that there are 1,000 micrograms in a milligram. And I know that my order now is 0.5 milligrams. And now I can plug in what I have available. Just the 1 milliliter. Sorry, that's not supposed to be there. I apologize. 1 milliliter over the 0.05 milligrams. And I believe that answer is 10, which gives me 10 milliliters. You could have also converted milligrams to micrograms, and then you would have just multiplied this number here by 1,000. So 500 over 50 would still give you the same answer, 10 milliliters. All right, question 22, sorry. So question 22 is very similar to question 21. You're going to take your order and you're going to multiply it by the strongest concentration. Keeping in mind that the strongest concentration is the one that has the most units per milliliter. Okay, so where people get tripped up on this question, and I'm just going to show you an alternative version of this. This right here, this milliliters diluent added, and I apologize, I know it's a little bit blurry, but this milliliters diluent added, this has nothing to do with any of the math we're doing. This just tells the pharmacy how much water, deionized water, to add to the powder to get to the concentrations listed here. And so this is what would be on the label. Okay, it would just be written out in the label. So if the pharmacy wanted to make 250,000 units per milliliter for a like a weaker dosage, mid-range dose, and then the strongest dose would be the 1 million units per milliliter. So there'd be different reasons to choose different strengths. But since the question tells you to choose the strongest concentration, that's why we're using the 1 million units per milliliter solution. So for your question, it says 750,000 units. And then you're just going to use the 1 million units per milliliter. And then as a side note, sometimes this is helpful, especially if you are, if you're ever typing this into the calculator and you're worried about making mistakes, take the number that has the fewest zeros. So this has 4 here and there's 6 here. I'm going to eliminate 4. I'm going to eliminate 4. So 75 over 100 is easier math and easier to plug into your calculator than 750,000 over 1 million, especially those little 10 key calculators that they're going to give you to use on the test. So, and I believe Jared gave us the right answer there, 0.75 milliliters. And that's your final answer. You do not round that to 0.8. It's a number less than 1. So you leave it rounded to the nearest 100th place. And if you haven't seen it already, you will at some point see that there are syringes that have, you know, they can go all the way down even into the thousandths place with making these, you know, with these injectables. So you can have something that's like 0.825 milliliters or even microliters, depending on what you're doing. Okay, yeah. So for someone had asked about question 19. Yeah, so when the question asks you to calculate the rate milliliters per hour, and if you already have milliliters and you already have per hour, you do not need to convert that to minutes. You just leave it as it is. So you would just take, so number 19 is the Ringer's lactate question, 375 milliliters over 3 hours. And then you would just reduce this to 125 milliliters per hour. Believe it or not, this question, number 19, is commonly missed because you're looking for more math to do. It's just reducing 375 over 3, and you get 125 milliliter per hour, and that's your answer. There's no dimensional analysis for this. It's just reducing volume over time. So another way of looking at that is if you're on the interstate, you've been driving for 2 hours, and you know that you've covered 120 miles, you would take your 120 miles divided by 2 hours. And then without looking at your dash, you can say like, oh, on average, we're driving 60 miles per hour. Okay. All right. All right, Diane's iPad 16. Okay, so 16 says that the tubing package is labeled as shown. We have the dextrose 5W IV solution, and it's infusing at a rate of 75 milliliters in 25 minutes. What is the flow rate in drops per minute? Now, Some places they use what's called microtubing. And so sometimes you're not given the drop factor. So if you ever ask something and they're saying they're using microtubing, the drop factor for those is 60 drops per milliliter. So what I was doing is just pulling up the next question here. Okay. So we're looking at, for me, I have this marked as question 23, but this is where you find the 15 drops per milliliter. Okay. And then you can see it's on mine, it's 75 milliliters, on yours, it's 75 milliliters in 25 minutes. So remember flow rate, it's when we're calculating drop rate, it's flow rate times the drop factor times the and then making sure your flow or your final answer is in drops per minute. So we have 75 milliliters that's supposed to infuse over 25 minutes times my drop factor of 15 drops per milliliter. Okay. And then we just do the math. So 75 times 15 divided by 25, or if you reduce this, you get 45 drops per minute. Do not convert minutes to hours and then go back to minutes. That's a wasted step. Only if it's already in minutes and your final result is in minutes, leave it in minutes. The only time you should really do any kind of converting here is if this is in hours. So if it were 75 milliliters per 3 hours, then you would convert hours to minutes and then go about solving that type of equation. And then the links that I had put in the chat, by all means, please share those. Those are not meant to be secret. Please share them. There's the practice test for every semester is in that link. So it'll, and unless the school decides not to do, Microsoft products anymore, it'll be that same link. Yeah. All right, were there any questions that I didn't go over yet that I may have missed? All right, so make sure when you're practicing these things, make sure you're paying attention to your units. If it's asking for teaspoons versus milliliters, make sure you're paying attention to what the question is asking you. If there's a question about when there's rounding involved, make sure you pay attention to your rounding rules, which are at the front of your packet. Remember that when it comes to drops per minute, we don't round these. You don't have you can't have decimal drops. So like if this was 44.99 drops per minute, it's 45. So you'd round to the nearest whole drop. But on your actual test, there shouldn't be anything where you need to round these with. But if I don't mention it to you, that might creep up on you and you might get upset about it. So. And I do realize that some of you, this is your first time looking at the practice test. So if you're just now going through it, just know that I'll also be here this afternoon for your class. And then I'll also be here this and then I'll be here on Thursday in the early afternoon and the late afternoon for your class. Yeah, you would. So someone asked about who to contact about your exam, your instructors. So whomever your instructors are, that's who you want to contact. I don't know which instructor runs the exam, but that's who you'd want to talk to. Yeah, because I don't think you have too many nursing instructors. I want to say you have maybe 2 to 4. I'm sure if you send it out to at least one of them, you'll eventually get an answer. But I would just say just be prepared. I know it's during your lab. And then that's it. So yeah, you should have an answer key to your practice test. Let me see. Should be the last page. Yeah, it's in the last page. So John, if you're looking for the answer key, it's there. It's at the end of the practice test. That's okay. Just wanted to make sure I've been diligent about including the answer. And then I will say, if you find that the key is wrong, there is a few questions where sometimes the key got messed up, meaning that I had another question that I didn't change the answer to. So if you run into something like that, you can email me or bring it up in the reviews, and I promise I'll get it straightened out for you. Because a lot of times you're right, I just miskeyed it when I made it, because I made this a long time ago. I made it, well, it feels like a long time ago. I made it in 2016, 2015. So it's been a little while since I've made these tests. And if you're looking for more practice similar to those infusion rate questions, I put something together for additional practice for the 240 students. And there are some flow rate type questions in there. So if you see that in the OneDrive folder, feel free to attempt those, because you'll see them next semester and then obviously 4th semester. But they might be helpful and they're different questions. So. Yep, you're welcome. Yep, you're welcome. So just keep practicing. And if you come across something you're not quite sure how to solve, either get back on with me on one of these reviews, or just email me and ask me, and I'll try and either point you to where I've already done it on YouTube, because I've done a lot of these questions already, or I'll create a new video for you. So, all right. Well, if I don't see you guys again, good luck on your test next week. I think you're going to do fine. So